The advancement of heavy-duty mine truck suspension systems is not merely a topic of interest, but a pressing necessity. With the potential to revolutionize the efficiency and safety of mining operations, this critical component of heavy machinery demands our attention. Dr. Nurul Hassan, a leading researcher in this field, is central to our discussion today. The focus of our discussion, led by Dr. Hassan, centers on the research methodology behind the study of Magnetorheological polymer gels, or MRPG, in haul truck suspensions. The methodology is built on 5 main pillars. Firstly, the utilization computational fluid dynamics, or CFD software, allows for the simulation of MRPG behavior within the dampers. Second, the implementation of finite element analysis, or FEA, provides insights into MRPG materials under static loads. Thirdly, the methodology incorporates experimental testing. Fourthly, the methodology includes a performance evaluation. Lastly, the methodology involves data analysis and validation. Each stage of the process is crucial in its own right. The methodologies collectively ensure a balanced approach, combining theoretical precision with practical applicability. This all-encompassing approach to research maximizes the reliability and effectiveness of the research outcomes. For further collaboration or inquiries, Dr. Nurul Hassan can be contacted via email at nurul.hassan@uk.edu.au. As for data collection and analysis methods, they are structured into 3 critical areas: experimental data, simulation data, and analytical data. Experimental data is gathered from bench tests and field tests, while simulation data is derived from fluid flow and quasi-static behavior simulations. Analytical data, on the other hand, is generated from the statistical analysis of the experimental and simulation data. This multifaceted methodology ensures a holistic understanding of MRPG in haul truck suspensions, paving the way for significant advancements in heavy-duty mining operations.